So in this lecture, we're going to be continuing on with our conversions using the factor label method, using our dimensional analysis, which is another way of saying using our units. Now, if you notice, I have a bunch of converting factors here. So these are, I should say, conversion factors. Now, the conversion factors that are outside of the metric system are not as clean as the metric system. The metric system has a 1 to 10 ratio, or a 1 to 100 ratio, or a 1 to 1,000 ratio. In fact, as we saw, it could be a 1 to a billion ratio. And if we have suffix to tell us how many or how little of the one we have. No matter what, we're just using decimal places because it's based on the powers of 10. It's a nice clean system. But before the metric system, we didn't have a nice system. We had what? A yard, or 8 pints equals a gallon. I know a lot of people know that, but there's some other things people don't. 1 pound is 16 ounces. It's not a 1 to 10 ratio, it's a 1 to 16. So you can't move the decimal place. You've got to take your calculator out to find these answers. So what we're going to do in this unit, this worksheet, or this video lecture, I'm going to show you how we use the metric system, which is a continuing on the skill that we first built in 1.1, and we're going to apply it with 2 or 3 step conversions. You cannot do this without factor label. So let's just get started. So let's start with an easy one. I want 10 inches to centimeters. Notice inch is a unit of length. It's an old English unit. Centimeter, which is 1/100th of a centimeter, is also a unit of length, but they're very different. We can't use an old or new way of metric system. So what we're going to have to do is use a converting factor. So the first step in all problems is take the number given to us and we write that. So let's start with 10 inches. It's the easiest thing to do. Write the number that's given. Now, we're going to times it, as we've been doing before, with a converting factor. I want to get rid of inches, so I put the inches on the bottom. Why? Because that will round the inches away. And I want centimeters to be up top, because I want that unit. The question is, do I have a converting factor of inches to centimeters? Let's see. 1 inch equals 2.54 centimeters. That's my converting factor. That is not something you will ever have to know. These will always be given to you. Okay? But 1 inch is 2.54 centimeters. So I put 1 here with the inch, and I put the 2.54 centimeters here. Not nice and clean. So take 10 and times by 2.54 centimeters and divide by 1. I know I set this up right because the inches cancel. And this gives me, okay, 25.4. We'll leave it like that. We won't worry about rounding. For those that are saying you're not rounding right, we'll get back to this in another time. Okay, and of course it's not inches, and I know that I would have gotten this problem wrong if I wrote inches because centimeters were left standing. All right, so this is a nice way to keep things nice and even. If you said to me, do I move the decimal place left or right? In this case we did because it was 10, but for the rest of the ones, this is not about moving decimal places, it's about using your units. So the answer is 25.4 centimeters. Remember, a number without a unit is meaningless. Let's move forward. Let's convert 10 inches into millimeters. Well, let's start from scratch. I know that I can take my 2.54 centimeters and continue, but let's start from scratch. Let's take 10 centimeters, or I'm sorry, 10 inches. I'm reading the word, but I'm not saying it. 10 inches. We're going to get rid of inches to get centimeters. You say, why? Well, let's get rid of inches. And if I wanted millimeters, I'd put that right here. So all I need is a converting factor between inches and millimeter. Here was it between inches and centimeters. So let's go look. Let's see, I don't have any other inch. It's the only thing that I have is this. It'd be nice to have an inch directly to a millimeter, but I don't. All I have is an inch to a centimeter. So I can convert to a centimeter. Could I also, after that, convert into a millimeter? Yes, because a millimeter and a centimeter are connected only by a power of 10 or one decimal place. So because I don't have a converting factor directly into centimeters, okay, into millimeters, I first convert to centimeters. So let's do that. So this is going to be a two-step problem. And if you don't use your units, guys, this is going to be really lost on you. That's why I had you do it this way initially for the one-step problems. So for every 1 inch, there's 2.54 centimeters. I got to get rid of this millimeter because I don't have that yet. I have centimeters. This is my converting factor. Right, this box right here. Okay, so this I got from the box above. Okay, you don't have to know that. That'll be given to you. Look what it does. Inches go bye-bye, and I'm left with centimeters. Now, I know it's the same thing as I did above. I could solve for that, but the big boy, big girl way is to keep going. Times it by another converting factor, right? I can times it by 10 and have a number, but I don't care. I want millimeters. So inches are gone, centimeters are left standing. If I want to get rid of centimeters, where would that go? On the bottom. Sounds like something I've been saying over and over and over. I want millimeters. Now, King Henry died drinking cat milk. This is centa. This is milli. This would be my 1 meter. That goes right in the middle. So centa is bigger than a millimeter by just one movement, therefore by 10. Now, who's the bigger unit? Centimeters bigger by 10. So you get the smaller number. The smaller unit gets the bigger number. And look here, centimeters cancel, and now I'm ready to come up with my number. Watch, 10 times 2.54, which is 25.4, divide by 1, still 25.4, times 10 gives me 254. What's the unit? Waiting for it. What's the unit? What's the unit left standing? Millimeters. See how organized I am using the factor label method or dimensional analysis? I'm starting with the unit I want. I cancel it. It tells me where this information has to be. Then I cancel the centimeters. And notice I had what? 2 different converting factors. This one in orange had to come from some other information. And this one I already should know from the first skill that we did. Okay? So let's move on. I would like you to try number 3. And so pause the video right now and try number 3. When you play it again, I'm going to reveal, okay, my work. Go ahead and stop me now. Okay, voila, magic. Look at this. I got 122.472 kilograms. How in the world did I do this? How did I know how to go from pounds to kilograms? Pounds is an old English unit, kilograms. I needed a converting factor. So hopefully you looked in the box. It's not something you have to know. And I see 1 pound equal 0.45, maybe if you can see it there. Okay, let's do this again. 1 pound is 0.4536 kilograms. So it's a one-step problem, but it was there. Now, truthfully, we're going to learn at this point that this should be rounded to 120. Someone out there who knows this, we're going to round this to 120. Get rid of that point there. It's approximately 120 kilograms. I don't care right now if you didn't know how to round. The raw number is good for me right now. We'll get back to that. Okay? It was a one-step problem. But just think with me. What if that was they wanted grams? Is there a pound going to grams here? No. So what we do is convert to kilograms like we did. And what if I wanted grams? Well, let's just pretend they wanted grams. How would I do this problem? I'd continue it the same way, except now I'd have to get rid of kilograms, right? So I want to cancel my kilograms to get grams. KJ is kg, I should say, is a abbreviation. Now I know kilo means 1,000, so there are 1,000 grams to 1 kilogram. Kilogram's a bigger unit. Okay, King Henry died drinking, okay, drinking cat milk, but this would be the gram. Gram goes in there. It's the mass unit. So kilo is 1,000 times bigger than a gram. It takes 1,000 of them, so the small unit gets the bigger number, and that's how you would do it. Okay, it's not part of the problem, but let's continue on. Now, this next question, 25.6 U.S. pints of blended roaches. Good. Wants to go to how many liters? So they give you U.S. pints, and they want to how many liters? So let's see if there's a pint to liter. Okay. There is no pints directly to a liter. Do you see that? I don't see pints to a liter. But what do we have? We have pints to 1 gallon. And then, what else could we do? If we do pints to a gallon, couldn't I convert the gallon into liters? Yeah, so how many steps would this be? It'd be 2 steps. So let's just walk you through it, and this will be the last one I show you. All right. So let's do this one. We're skipping number 4 because I'm being crazy. I'll write down the number that's given to me, 25.6 U.S. pints. We'll just put pints here. We want to get rid of pints. That's the unit we don't want anymore, so pints go here. Now, we wish we had liters directly. We'd be all set, but we don't. So we got to take our pints and convert to gallons. And then once we're in gallons, we can convert to liters. So 8 pints equals 1 gallon. So 8 pints equals 1 gallon. We can assume it's a U.S. gallon. All right. Pints cancel. I don't care what this number is right now. You could multiply it by 1 and divide by 8 if you wanted to, but I don't care. I want to go to liters. So I have to do my second step. I want to get rid of gallon. And I want liters. So I go up to my second one, and 1 gallon is 3.785 liters. 3.785 liters. 3.785 liters, I think. I got to check. My short-term memory is gone at this height. 3.785. And that's for every 1 gallon. Notice the gallons cancel. Try doing this without the units. It makes it so organized. All right? That's why you have to learn this method. You'll do it in physics. You'll do it the rest of your science career. 25.6 times 1. Right? All I'm doing is taking this number and times it by 1, then divide by 8. Okay, I hit enter. Then times that result by 3.785. And if you have to, divide that result by 1. And what you get is 12.112. And let's clean this up. And what I always suggest to tell people is try this a couple times in your calculator just to make sure you didn't do a big finger error like I do. Now, of course, this is wrong right now because I didn't write the what? I didn't write the unit. What do we have? Who's left standing? Liter. Okay, so 25.6 times 1, you really don't have to do that, but divide by 8 times 3.785, and I get 12.112. Now this would actually round. It's okay you don't know this. I'll take this right now. But this will round to 12.1 liters. 2-step problem. Okay? So what I would like you to try is number 6 and number 7. And number 4. Try those for size. I have the key posted. Thanks for playing.